In this lecture, I'm going to be teaching you about significant figures, where they come from, and how we identify them when we don't see the measurement device that they were born from. It should be clear to you that when we measure, we give birth to numbers. Yeah, numbers have come from somebody measuring. We first come up with a unit, some standard. For instance, in this thermometer, we're using degrees Celsius as our unit. And then we're measuring how high or low in each degree of centigrade or Celsius the temperature is. So if I'm going to measure, okay, we should know that the skill in measuring requires us to first measure and use all numbers on the device. Now you should know that on the measurement device, to give birth to a number, you should know that numbers themselves represent how many of a unit, but these little markings here, these calibrations also represent numbers. So when we measure with all the numbers on the device, and then at some point we have to guess. So in this measurement, I'm looking at this temperature here. As I scroll down, I can see that I am definitely certain of the number 20. So it's 20. And then there's 10 markings in between 20 and 30. So this is going to be a tenth of one of these 20 to 30. So from here to here, there's 10. And because these are tenths, it must mean that this is 21 right here. This is 22. This is 23, 24, this is 25, this is 26, and this is 27. They don't put all those numbers there because the markings will help us. Besides, it would be too expensive. So the number on the equipment plus this calibration, this marking represents a number. So what am I certain of? Well, I'm definitely certain that it's 20. Now, it looks to me, and this is where there's an open interpretation, that's a little below this 27 number or marking, right? 27, 28, 29, and 30. So I know that on this device, I am certain of 26. And it looks to me a little bit under, right? It looks to be a little bit under. So I'm going to say 26.9 degrees Celsius. Don't forget the unit. All right. Now, someone might say, well, I think it's right on the line, and someone could report 27, and because their guess is it's on a line, they would say 0.0 degrees Celsius. Notice, party people, that my guess is in the tenths place. I was guessing that it was just below 27, so 26.9. Someone else could read this and interpret this to be 27 they're certain of, but they're still guessing if it's right on the line, so they said 0 is their guess. And you should know that every measurement has error in it, or we say uncertainty. Why? Because of the guess. Every measurement requires that you have all the numbers on the device and the guess. Okay, the guess. And we say that these numbers that we get from the measurement device, including the guess, are significant. Significant digits mean that they are numbers that came from directly a measurement device. We didn't make them up. They weren't estimates except for the last number, the guess. So when we measure all the numbers, including these little numbers that are represented by markings, calibrations, and then we guess in between the next calibration. All right, so at some point in all measurements, we have to get to a point where our measurement is in between the last two markings, and we have to apply a guess. So significant figures or significant numbers are all the numbers that come from the device plus the guess. Now, as a little review, when you have a precise or an instrument that has a lot of precision, the guess is in a smaller part of the overall number. Let me give you an example. If you look at this number here, okay, so let's say that I have a measurement that came from a triple beam balance where I'm measuring mass, and the unit of mass is grams. And I was given this measurement to me in a lab report from someone else's laboratory. And what I can do is by looking at the number, and of course the number is 24.7894 grams, the number below. And by the reporting of this number alone can tell me what numbers are significant. And significant figures are numbers that come directly from the measurement devices. Now, numbers that come from the measurement device include all the numbers that we're certain of, which means either it was on a line itself, okay, or calibrations in between numbers, okay, and including the guess. So if you look, all of these numbers came from the measurement device. So this is 1, 2, 3, 4, 5. There are 6 significant units that come from this number. So this number has 6, as we would say, 6 sig figs. Now what's significant about these figures? They're significant because they were given birth or given born by the measurement device. Numbers had come from somewhere, somehow, down the line. Numbers were given birth by measurement devices. Numbers didn't pop up. Someone measured something somewhere and we got numbers. So what makes these measurements so important is it makes numbers that are significant when they come directly from the measurement device. But what's important is the number tells a story about the type of device that was used to get the number. What I mean by that is 24.7894 must have been a device where all of these numbers that I'll do in green came from the calibrations. There's certain digits, as we say. And then, of course, the last one is the uncertain digit that we guessed from. But that includes all of my significant figures. Even the guess is significant because it was based on some kind of standard in between some calibration. So the point I'm trying to say here is that if I have a number, it can tell a story about the device. What does it mean? Well, if I have 24, and let's clean this up because it's getting kind of crazy, but if I have 24.7894, this of course is my guess, which means the calibrations on the equipment stop at the what place? Well, this is the tens place, this is the hundreds place, this is the thousands place. So I have a device that is calibrated or marked to the what place? To the thousandths place. That is very precise and very expensive. So why do we care about significant figures, numbers that come from devices? Why is it that important? Well, we care because there are going to be some numbers that come from the device, believe it or not, that are non-zero numbers that confuse us. For example, if I was to write a very small number, 0.00123, let's say grams. This is a very precise instrument because we're measuring out to a very small number. Our guess is what? Tens, hundreds, thousands, 100,000s place. Our guess is in a small area, so this is definitely very precise. Now, you'd say, Mr. Grodsky, all these numbers came from the measurement device. Yes. So all non-zero numbers are significant. 1, 2, and 3 definitely came. But what about these zeros? We all know that anytime I measure something and get numbers, they all come directly from the measurement device. So all non-zero numbers. Now, what about zeros? Well, these zeros here help us get to what? A very small part of the number. They help me get smaller. So these zeros are placeholders. So therefore, they don't count. The measurement device probably starts being able to measure at this part here. These help us get out to the small number. So leading zeros never count because they're placeholders that help us get out to a small number. Now, what about zeros in between other zeros? Like, for instance, if I had 100 and 102, let's say, centimeters. Well, clearly this is my guess, the last number, right? So these two had to come from the measuring device to get to the guess. So therefore, this would have 3 significant numbers, just like this one has 3 significant numbers. So this 0 is a sandwich 0. A sandwich 0 is always significant because it's around other 2 numbers that definitely come from the measurement device. It's not a placeholder. What if I have a large number? Like, for instance, let's say I have 17,000, I don't know, tons or something. Well, this device can measure something heavy because it's not very sensitive on a small scale. 17,000 starts measuring probably out here, like they use when they measure cars on the side of the road that are too heavy. So this is my guess, and this is the number on the device, or this is the number we got directly. So these 2 numbers are significant. So you would say that these zeros are, again, placeholders. Why are they placeholders? They're helping me become a big number. Things that are heavy can, guess what, can only be measured by equipment that's not that sensitive. If it was, it would break. Things that are light are measured by things that are sensitive that could never measure the heavy stuff. So things that are small need placeholders to get out to the small number. Things that are heavy need placeholders that get out to the heavy. So these ending zeros here do not count, and this number has 2 significant numbers. So what I'm doing here is I'm looking at a number and identifying what is significant, not knowing what the device looks like. Back to the original thing. A number that we get from a measuring device should reflect the device. What I mean by that is it tells a story how we got it. 26.9 says to me the 0.9 was a guess in the tens place. Okay? Which means if I'm guessing the tenths, whole number integers better be on the device. And my friends in chemistry, that's what we have here. These are whole number integers, these lines. So the guess is not calibrated. So you should be able to draw the equipment based on the number. The number we get tells a story about the equipment that was used. It's very important. But sometimes we don't have the equipment. We just have the raw numbers given to us. So very simply, if you're given a number like 88 centimeters, that has 2 non-zero numbers, that has 2 significant numbers that came from measurement device. This was my guess, this was on the device, both numbers are significant. If I have 808 centimeters, well, this was my guess, and these 2 numbers we got directly on the device, that has to be 3 significant numbers because significant numbers are numbers that come from the measurement device. That's a sandwich 0. Now, if I have 808,000, that still has 3 significant numbers because these ending zeros, are what? Not significant. They just help me get out to this point. So this was my guess still. All right. If I had 0.0000808, okay, well, these zeros are just placeholders. This is a sandwich 0, and you're right, this would be 3. Okay, now there's one little trick with these zeros. Anytime you've got leading zeros like 0.0011, they're never significant because they're placeholders making the number smaller. So this would be 2 significant numbers. If you've got ending zeros like 2,800 centimeters, these 2 do not count because there are zeros helping us get out to the big number, and here's our placeholder. Here's our guess right there. But the only little caveat here is that, only little trick is sometimes, what if those numbers were measured? Like over here. Look at this, party people. Didn't we measure 27.7, 27.0? Didn't we measure this? Or at least that was one of the numbers someone could have gotten from this. So sometimes the zeros are significant. How do you know? I'll tell you. If you've got a decimal point present, the ending zero counts. So this would have to be 3. Wait a minute. Wait a minute. Looking down here, 2800 is only 2 because there's 2 placeholders. But if you put a point here, that becomes 4. So if I have 19,000, as written, that's 2. But once you put a point, you're telling me that we guessed there and this was measured. Now you don't do that with small numbers because a decimal point is always there for a small number. So this would be how many significant figures? Just 1. If a decimal point is present, ending zeros don't count. And that's how it works. And here are some rules. But you can do this without the rules if you understand. Significant figures are numbers that come from measurement devices. These devices give us numbers. Sometimes they give us zeros, and those zeros will be significant if they're what? Sandwiched, okay? Or if there's a decimal point present, the ending zeros will count. The leading zeros never count because that is always trying to make a small number. So let's try these 5 questions together. All right, let's zoom it up a little bit. Okay, and by the way, these mighty rules of sig figs are in your notes. That's where I got them from. I printed them out for you, I believe, or you have them on the class website. But let's get going. So the first one is 0.00010. Well, it's a small number. And to measure this number, to see what numbers would come from the measurement device, which is the same thing as saying who are significant, we got to get rid of placeholders if there are any. And to come out to this number, we have 3 placeholders. These leading zeros never count because all they're doing is getting us out to a small number. So leading zeros never count, so they don't count. Now this ending zero, so you know what about this ending zero? Well, this ending zero counts because there is a decimal point present, so that was measured. So what we have is 2 numbers. Okay, this last 0 must have been measured and was our guess. So this is 2 significant figures, or 2 numbers that came right off the device. All right, the next one. Why don't you pause me and try that? Okay, assuming that you just don't want to do that and want to listen to me, here's how I would do it. Okay, I look at the number and I see that I have zeros that are sandwiched around numbers. Well, if I've got a number here, that means that this one was my guess, and all of these must have been on the equipment. So that means they're sandwich zeros, or it means that all the numbers must be significant because they're sandwiched around the ones. So we would say 1, 2, 3, 4, 5 numbers came. All of these numbers came from the measurement device. Or the zeros here are count because they're sandwiched. The next one, you could pause me and try yourself. Okay, assuming that you just hit me, let's continue. So this is 1, 2, 3, 4, but wait a minute, this is a big number, 10,000. But, my friends, in chemistry, these are placeholders to get out to the number that I measured. The, what, non-zero numbers always count, right? So I got 1 definitely, but these zeros at the end don't count because they're placeholders. They get me out to the 10,000s place. So this has 1 significant unit. However, if there was a decimal point, what happens is that means that this was measured and now it would be 5 significant figures. Of course, there is no decimal point, so that means those zeros are placeholders. Remember that if a decimal point is present, all the ending zeros count. That's what this rule is. All right, it makes sure that we measured that they're no longer placeholders, they're on the equipment. That's what this is about. How many figures did we get from the equipment? Essentially, we're taking out the zeros that are placeholders. That's what the rules of sig figs does. Okay? All right, here we go, 0.1010. Okay, you try that. Pause me. Okay, assuming that you hit play. Leading zeros never counts a placeholder. This ending zero counts because a decimal point is present, so that counts. This zero counts because it's sandwiched between ones. So if you put 4 significant figures, you're understanding this. Good for you. If you didn't, keep going. All right, next one. Pause me. And you should have tried this one. Well, I know that this zero counts because it's sandwiched. I know that non-zero numbers always count, and I know that this zero counts because it's at the end and there's a decimal place. So again, the whole point of this is to figure out what zeros do count, what were measured and what were placeholders. All of these zeros were placeholders, so there's 4 significant figures. If you want to go through the rules, all non-zero numbers are significant. This zero is sandwiched, and this ending zero counts because a decimal point is present. Please try the worksheet, the first part, A through V, I believe. Try that. Look at the key, see how you did. The whole point is you're trying to figure out what numbers came from a measurement device, or better yet, what zeros are being placeholders. Good luck.